Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content, please press like, share and subscribe. Press the bell icon to get the notification. If you are first time viewing this video and directly this channel, then I will suggest you to go through my introduction video first to understand the presentation structure of course content. Today we are at the workshop session 1 for mathematical induction. Okay, we are at workshop session 1. Before this workshop session, we had completed the introduction of mathematical induction. We had completed detailed explanation classes 1 and detailed explanation class 2. Okay, so I will suggest you to go through this sequence and after that come to this video. Now, to cover your board content, I had prepared 2 workshop sessions in this chapter of mathematical induction. That will be workshop session 1 and workshop session 2. In these 2 sessions, we will be practicing some problems which will be of board level. Okay, which will be of your board level. Now, we are practicing some problems of different varieties. If some problems are skipped, then there is a whole reason that such type of problem is covered already. Okay, that type of problem is taken care already. With this introduction, let's start our workshop session. Now, the first question is on your screen. Now, my problem is, Pn statement is 1 cube plus 2 cube plus 3 cube to n cube equal to n plus 1 by 2 whole square. So, in simple terms, the sum of cube of first n natural numbers is n plus 1 by 2 whole square. Okay, so this we have to prove. So, first step is to check for P1. For my P1, what will be my L.H.S? My L.H.S will be 1 cube, which is equal to 1. What will be my R.H.S? My R.H.S will be 1 plus 1 by 2 whole square. Okay, in place of n, substitute 1. Then you will get it as 2 by 2 whole square, which is equal to 1. So L.H.S equal to R.H.S. My L.H.S equal to R.H.S, P1 true. Let's come to PM. For my PM, I will come up with a concrete statement, that is 1 cube plus 2 cube plus 3 cube. This is my assumption step. So I will assume that sum of the cubes of first m natural numbers will be m plus 1 by 2 whole square. Okay, now I will go to my Pm plus 1 step, which is the induction step. This will be my Pm plus 1, my L.H.S. 1 cube plus 2 cube plus 3 cube dash dash up to m cube plus m plus 1 whole cube. Okay, this is what my L.H.S for Pm plus 1 is. Now, by seeing the R.H.S of the problem statement, I can anticipate that how my R.H.S of Pm plus 1 will look like. So, how my R.H.S of Pm plus 1 will look like? You substitute m plus 1 in place of n. Then your R.H.S will be m plus 1, m plus 2 by 2 whole square. Okay, this is how your R.H.S should look like for Pm plus 1. So our aim is to get this from this. Now first m terms we can substitute from here. So once we substitute from here, we will get m plus 1 by 2 whole square plus m plus 1 whole cube. Okay, now in these two, m plus 1 whole square is common. Okay, from these two, m plus 1 whole square is common. So if I will take m plus 1 whole square common, and I will be left with m square by 4. Just to square this, then you will get m square, m plus 1 whole square by 4 plus m plus 1 whole cube. So m plus 1 whole square is common. So you are left with m square plus 4 in this. And here you are left with m plus m+1, as it is m plus 1 whole cube. As it is m plus 1 whole cube, you will multiply it, you will get m plus 1 whole cube. So m plus 1 whole square is common in this. Further solve it, you will get it as, you take LCM here, 4m plus 4 by 4. So m square plus 4m plus 4, it will be your m plus 2 whole square. So you will get m plus 1 whole square, m plus 2 whole square by 4. Okay, now this one you can simplify it as m plus 1, m plus 2 by 2 whole square. Okay, so you got the same thing which you had anticipated. Okay, so this completes our first sum. Chalo, second sum is on your screen. So my problem is, Pn statement is 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dash dash up to 1 by 1 plus 2 plus 3 plus up to n. Okay, so we are seeing the sum of first n natural numbers, sum of first two natural numbers, sum of first three natural numbers. All those things are written in denominator and they are added. Okay, so this is what my LHS is. Now what is my RHS? My RHS is 2n by n plus 1. Okay, 2n by n plus 1. This I have to prove that this LHS is equal to RHS. Okay, now let's get started. First step is for P1. For P1, what is my LHS? LHS is first term, which is 1. My RHS in place of n I have to substitute 1. So it will be 2 into 1 by 1 plus 1, which will be equal to 1. So LHS is equal to RHS. Check is done. Now assumption step. Concrete statement will be 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dash dash 1 by 1 plus 2 plus 3 plus up to m is equal to 2m by m plus 1. So in place of n I had substituted m. So this is the concrete statement which I had derived. Okay, this is the concrete statement which I had derived. Now my pm plus 1 will be, so this is my third step. For pm plus 1 it will be 1 plus 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus dash dash up to 1 by 1 plus 2 plus dash dash up to m plus 1 by 1 plus 2 plus dash dash up to m plus 1. Okay, so why I had written m step? Because I want to substitute my pm thing over there. So whatever is my PM, I will substitute that value over here. So this entire value is substituted by 2m by m plus 1. Okay, because it is 2m by m plus 1. Now plus 1 by 1 plus 2 plus 3 plus dash dash up to m plus 1. Okay. Now you are familiar that sum of first n natural numbers is n plus 1 by 2, where n is number of natural numbers, right? Here, how many numbers are there? This is m plus 1, right? So what is the sum of first m plus 1 natural numbers? It is m plus 1, m plus 2 by 2. So in place of n plus 1 by 2, you have to substitute n is equal to m plus 1. Okay, you have to substitute n is equal to m plus 1. In n plus 1 by 2, if you substitute n is equal to m plus 1, then you will get m plus 1, m plus 2 by 2. So that will be the sum of first m plus 1 natural numbers, right? So it will be 2m by m plus 1 plus m plus 1 m plus 2 whole by 2. So this is the sum of first m natural numbers. Now m plus 1 is common in this. Let's take that common. Let's take this out. So 1 by m plus 1 is common. You are left with 2m plus 2 by m plus 2. Okay, 2m plus 2 by m plus 2. Now take m plus 2 as LCM and solve it further. Then you will get it is 1 by m plus 1, 2m square plus 4m plus 2 by m plus 2, right? Now you take 2 common, then it will be m square plus 2m plus 1. Once you take 2 common, it will be m square plus 2m plus 1. Now m square plus 2m plus 1 is m plus 1 whole square. So you will get 2 into m plus 1 whole square. Okay, and this will be m plus 1 and m plus 2. So I will use this side of the board. It will be 1 by m plus 1. You take 2 common, then it will be m square plus 2m plus 1 by m plus 2. Okay, now it will be 1 by m plus 1, 2 into m plus 1 whole square by m plus 2. Now 1 m plus 1 will get cancelled. So your final answer will be 2 m plus 1 by m plus 2. Okay. Now what should be my RHS of PM plus 1? For that, let us substitute m plus 1 here. Then we will get 2 into m plus 1 by m plus 2 if we substitute n is equal to m plus 1 over here. So we see both of them are, sorry, not this one, both of them are matching, right? So 2 into m plus 1 by m plus 2, which we got from our PM plus 1 step. So our RHS is true, right? So this completes our second problem. Third problem is on your screen. Okay. So my third problem is 1 into 2 into 3 plus 2 into 3 into 4, like that, n into n plus 1 into n plus 2, okay, is equal to n plus 1, n plus 2, n plus 3 by 4. If you see in literature point of view, it is product of three consecutive natural numbers sum. Okay, sum of the product of three consecutive natural numbers. So sum of the products of three consecutive natural numbers are like 1, 2, 3 plus 2, 3, 4 plus 3, 4, 5. Okay, is equal to n, n plus 1, n plus 2, n plus 3 by 4. Okay, so this is what we have to show here, right? Chalo, let's get started. So first step is of P1. So for P1, what will be my L.H.S? My L.H.S will be 1 into 2 into 3, which will be 6. What will be my R.H.S? My R.H.S will be 1, 1 plus 1, 1 plus 2, 1 plus 3 by 4. So this will be 1 into 2 into 3 into 4 by 4. 4 got cancelled, it is 6. Okay, so my L.H.S is equal to R.H.S. So my P1 is true. So what I had done, I had substituted n is equal to 1 in R.H.S, and in L.H.S it is my first term. So this L.H.S is equal to R.H.S. Now second step of PM. PM concrete statement from this assumption is so these all are M. So M, M plus 1, M plus 2, M plus 3 by 4. So it is product of first all three natural numbers taken in a order 1, 2, 3, 2, 3, 4, 3, 4, 5, like that, M, M plus 1, M plus 2. So this is mth term. This is equal to M, M plus 1, M plus 2, M plus 3 by 4. Okay, so this is my concrete statement which I got it from assumption. Now let's go to our third step, which is the induction step. This is our PM plus 1. So in my PM plus 1, I will have M plus 1 terms. So for M plus 1 terms, my L.H.S will be 1 into 2 into 3 plus 2 into 3 into 4 dash dash plus M, M plus 1, M plus 2 plus M plus 1, M plus 2, M plus 3. Okay, so these are first M terms and this is my M plus 1th term. So for M plus 1th term, what I had done, I had substituted n is equal to M plus 1. So when n is equal to M plus 1, then it will be M plus 1, M plus 2, M plus 3. Okay, now how my R.H.S will look like? In R.H.S, you substitute n is equal to M plus 1. Then we should get the R.H.S of our PM plus 1 statement as M plus 1, M plus 2, M plus 3, M plus 4 by 4. This is what we should get and this is our aim. Okay, this is what we should get and this is our aim to get the R.H.S of PM plus 1 statement. Okay, now let's proceed towards our aim. So sum of the first this M numbers, it is M, M plus 1, M plus 2, M plus 3 by 4. So you substitute over here M, M plus 1, M plus 2, M plus 3 by 4 and you are left with here M plus 1, M plus 2, M plus 3. Now in these two terms, What is the common? M plus 1 is common, M plus 2 is common, M plus 3 is common. So let's take all these three terms out. M plus 1, M plus 2, M plus 3. Now here you left with M by 4 and here you left with 1. Okay, here you left with M by 4 and here you had left with 1 in next term. So it will be M by 4 plus 1. Right? Now you take LCM over here, then you will get M plus 1, M plus 2, M plus 3, M plus 4 whole divided by 4. Okay, so this is what we got. We had anticipated that our RHS will be M plus 1, M plus 2, M plus 3, M plus 4 by 4, and we derived that RHS from Pm plus 1 statement. So Pm plus 1 is true. So my conclusion is Pn will be true. Right? This completes our third problem. Now fourth problem is on your screen. So my problem is Pn is 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus dash dash up to n into 2 to the power of n. So this is my LHS. What is my LHS? 1 into 2 plus 2 into 2 square plus 3 into 2 cube plus dash 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 up to n into 2 to the power of n. Right? This is equal to n minus 1 into 2 to the power of n plus 1 plus 2. Okay, so my RHS is n minus 1 into 2 into n plus 1 plus 2. 2 to the power of n plus 1 plus 2. Okay, so now we will solve this problem. Okay, so first let's go with our P1. For P1, what is my LHS? First term is 1 into 2. What will be my RHS? My RHS is, I have to put n is equal to 1 over there for my first term. So 1 minus 1, 2 to the power of 1 plus 1 plus 2. So this 1 minus 1 will be 0. So this entire term will be 0. So we are left with 2. My LHS is also equal to 2. So my LHS equal to RHS. So initial check is done. That P1 is true. Now let's come up with the concrete statement from our assumption step. So concrete statement from assumption step will be 1 into 2, 2 into 2 square plus dash 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 up to m into 2 to the power of m. Okay, this is equal to m minus 1, 2 to the power of m plus 1 plus 2. Okay, m minus 1, 2 to the power of m plus 1 plus 2. So what I had done, in my LHS I had substituted n is equal to m. Similarly in RHS also I had substituted n is equal to m. Okay, now come to my Pm plus 1. In my Pm plus 1 statement, how my LHS will be? My LHS will be 1 into 2 plus 2 into 2 square plus 3 into 2 cube dash dash m into 2 to the power of m plus m plus 1 2 to the power of n plus 1. Okay, m plus 1 2 to the power of m plus 1. This will be my LHS for Pm plus 1. Now entire this m terms you substitute from Pm. So you will get it as m minus 1, 2 to the power of m plus 1 plus 2 plus m plus 1 2 to the power of m plus 1. Now let's stop here and let us think that how my RHS of this Pm plus 1 will look like. Okay, this is the best practice to first anticipate that how my RHS will look like. So my RHS, in place of m you substitute m plus 1, then you will get m into 2 to the power of m plus 2 plus 2. So this is how my RHS of Pm plus 1 should look like. Okay, this is how my RHS of Pm plus 1 should look like. So let's proceed to get this. Okay, so in this one, now you open this bracket, so you will get m into 2 to the power of m plus 1 minus 2 to the power of m plus 1 plus 2 plus this bracket also you open, then you will get m into 2 to the power of m plus 1 plus 2 to the power of m plus 1. Okay, so what you had done, you had opened the brackets. Now in this 2 to the power of m plus 1, this 2 to the power of m plus 1 will be cancelled. Now this m into 2 to the power of m plus 1 and this m into 2 to the power of m plus 1 both will add and it will become 2 times of m into 2 to the power of m plus 1. This is same as m to the power of 2m plus 1. I will consider it as x, then this is x and this is x, it will become 2x. So it is 2 into x and x is m into 2 to the power of m plus 1. So that step I had done. Okay, after that we are left with 2. Let's keep 2 here. Okay, now this 2 into 2 to the power of m plus 1, it will become m into 2 to the power of m plus 2 plus 2. Okay, so this is what my RHS is. So this is same as what we had anticipated, right? So Pm plus 1 is true. Now as Pm plus 1 is true, our conclusion is Pn is also true. This completes the fourth variety of the problem. Now fifth is on your screen. So my problem is 1 by 2 plus 1 by 4 plus 1 by 8 up to dash dash 1 by 2 to the power of n, where n is number of term, is equal to 1 minus 1 by 2 to the power of n, or it is LHS can be written as 1 by 2 plus 1 by 2 square plus 1 by 2 cube dash dash up to 1 by 2 to the power of n. Okay, this is what my entire LHS is, and my RHS is 1 minus 1 by 2 to the power of n. So I have to show that. Okay, chalo, let's start the solution. First, let's see, check about P1. So P1, my LHS will be 1 by 2. Okay, my LHS will be 1 by 2, first term. What will be my RHS? My RHS will be 1 minus 1 by 2. This is also equal to 1 by 2. Okay, so my LHS is equal to RHS. So my P1 check is done. Now let's come to PM. In PM, this is the assumption step, and we will assume that sum of first m terms is equal to 1 minus 2 to the power of m. So it will be 1 plus 1 by 2 square plus 1 by 2 cube dash dash up to 1 by 2 to the power of m is equal to 1 minus 1 by 2 to the power of m. Okay, so this is the concrete statement what we derived from our assumption step, which is our PM step. Okay, now let's move on to our induction step, which is our main step. Third, for induction step of P of m plus 1. Now let's write my LHS. LHS will be 1 by 2 plus 1 by 2 square plus 1 by 2 cube dash dash 1 by 2 to the power of m plus 1 by 2 to the power of m plus 1. Okay, 1 by 2, 1 by 2 square, 1 by 2 cube, like that. So these are my first m terms. These m terms can be substituted from this concrete statement. So it will be 1 minus 2 to the power of m plus 1 by this 2 to the power of m plus 1. It can be written as 2 to the power of m into 2. So I will write it as 2 to the power of m into 2. Okay. So what I had done, 2 to the power of m plus 1, I had written as 2 to the power of m into 2. Now from these two terms, 1 by 2 to the power of m is common. So let's take that common out. 1 plus 1 by 2 to the power of m, and you will have minus 1 here. Here it will be minus 1 because there is a negative sign. So it will be minus 1 here. Now here it will be 1 by 2. Okay. So what we will do? We will perform this operation. 1 by 2 minus 1, it will be minus 1 by 2. So you will get it as 1 minus 1 by 2 to the power of m into 1 by 2. 1 by 2. So whatever is minus is there, it is consumed over here. So it will be 1 minus 2 by 2 to the power 1 by 2 to the power of m into 1 by 2. Now 2 to the power of m into 2, it will become 1 minus 1 by 2 to the power of m plus 1. Okay, it will become 1 minus 1 by 2 to the power of m plus 1. So you substitute n is equal to m plus 1 here. So that will be the R.H.S. So it will be 1 minus 1 by 2 to the power of m plus 1. Okay, that is our anticipated R.H.S or desired R.H.S. Okay, what we thought of earlier. So we thought that our R.H.S should be 1 minus 1 by 2 to the power of m plus 1 by substituting m plus 1 in R.H.S of the problem statement. Same R.H.S we had derived here. So with this we can tell that Pm plus 1 is true. So our conclusion is Pn is also true. This completes the fifth problem. Okay. Now sixth problem is on your screen. So the problem is, my Pn statement is 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus dash dash up to 1 by n into n plus 1 into n plus 2 equal to n plus 3 by 4 n plus 1 n plus 2. Okay. So this is my LHS and that is my RHS. So my LHS is 1 by 1 into 2 into 3 plus 2 into 3 into 4 plus 1 by 3 into 4 into 5, like that. 1 by n into n plus 1 into n plus 2. So this entire sum of the n terms equal to my RHS will be n plus 1 by n plus 3, okay, divided by 4 n plus 1 n plus 2. Okay, so this is my RHS. Right. Now let's start solving this problem. So first check for P1. So once we check for P1, my LHS will be 1 by 1 into 2 into 3. It will be 1 by 6. Okay, my LHS will be 1 by 6. Now what will be my RHS? My RHS will be, in place of n you substitute 1. Then it will be 1 into 1 plus 3 by 4 into 1 plus 1, 1 plus 2. Okay, so it will be equal to 4, 1 plus 3 is equal to 4, 4 into 1 plus 1 is 2 and 1 plus 2 is 3. 4 get cancelled, so this is equal to 1 by 6, right? So my LHS equal to RHS. Okay, so once my LHS is equal to RHS, P1 is correct. Okay, P1 is true. So my check statement is done. Now let's write my PM statement. My PM statement will be 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus 1 by plus 1 by m into m plus 1 into m plus 2 is equal to, now let's write our RHS. It will be m plus 3 by 4 into m plus 1 m plus 2. So what I had done, I had substituted n is equal to m over there. So once I substituted n is equal to m over there, so I got my RHS. My RHS is m plus 3 by 4 m plus 1 m plus 2. Okay, now what will be my m plus 1? Now let's go to our induction step, which is Pm plus 1. So Pm plus 1, my LHS will be 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 dash dash 1 by m into m plus 1 into m plus 2 plus 1 by m plus 1 m plus 2 m plus 3. Okay, so I had substituted n is equal to m plus 1 in the LHS. So I had come up with this LHS. So it has first m terms and this is my m plus 1th term. Now let's see how my RHS of this Pm plus 1 will look like. Let's anticipate that. So in this RHS, just put n is equal to m plus 1. So once you put, I will write it over here. So once you put n is equal to m plus 1 over there, then you will get your RHS as m plus 1 m plus 4 by 4 m plus 2 m plus 3. So this is how my RHS should be. Okay, this is how my RHS should be at the end. Okay, so I substituted n is equal to m plus 1. So let's work to get this RHS. Now I substitute this first m terms with this PM statement. So it will be m plus 3 by 4 m plus 1 m plus 2. Now here it is 1 by m plus 1 m plus 2 m plus 3. Write it down. M plus 1 m plus 2 m plus 3. Okay, now m plus 1 m plus 2 is common in denominator. Let's get that. M plus 1 m plus 2. Now we are left with m plus 3 into m by 4. So m into m plus 3 by 4, and in this we are left with 1 by m plus 3. So let's write it down. M plus 3. Now let's take LCM. Now once you take now you understood this, right? M plus 1 and m plus 2 is taken common. So we are left with 4 here and numerator as m plus 3. Here m plus 1 and m plus 2 is taken common. So we are left with m plus 3 only here. Okay, so we are left with m plus 3. Now this m plus 3 we will take as LCM, then you will get as 4 into m plus 3. Okay, so once you take LCM of 4 and m plus 3, it will be 4 into m plus 3. Now in this term, this m plus 3 will be multiplied. So it will be m into m plus 3 whole square plus this 4 will be multiplied here. So it will be 4. Okay, so this m plus 3 is multiplied here. This 4 is multiplied here. We have taken 4 into m plus 3 as a LCM. Okay, so this is the, now outside the bracket there is m plus 1, m plus 2. Okay, now m plus 3 whole square expansion is m square plus 6m plus 9. It is a plus b whole square formula, a square plus 2ab plus b square. So it is m square plus 6m plus 9. Now in m square plus 6m plus 9, you multiply this m inside. Okay, so let's write the step, entire step. Okay, let's not skip something. So 1 by m plus 1 m plus 2. Now this will be my m into m square plus 6m plus 9 plus 4 by 4 into m plus 3. Okay, okay, so 4. Okay, so what I have done, m plus 3 whole square, it is a plus b whole square. Now I will use this side of the board. So now you multiply this m inside. Once you multiply that, you will get 1 by m plus 1 m plus 2, which is common. Once you multiply, you will get m cube plus 6m square plus 9m plus 4 by 4 into m plus 3. Okay, so once you multiply m inside, so you will get m cube plus 6m square plus 9m plus 4 divided by 4 into m plus 3. Now we have to factorize this m cube plus 6m square plus 9m plus 4. To understand the factorization, please go through my operation classes. Okay, in operation classes, my operation classes, I had given the entire description that how to factorize the things. Okay, so let's be brief on this. So what we will do, we will substitute m is equal to minus 1 here. Once we put minus 1 over here, m equal to minus 1, then we will get minus 1. Here we will get minus 9, it will become minus 10. As we substituted minus 1 here, it will become 6 because it is m square. So it will be 6. 6 plus 4, it will be 10. Minus 9 minus 1 minus 10. 6 plus 4 10. So minus 10, 10 is cancelled. So minus 1, if we substitute in the place of m, then we will get the result as 0. So m plus 1 is factor of this. Okay, so m plus 1 is a factor of this. So let's write m plus 1 as its factor. M plus 1, m plus 2. Now m plus 1 is factor of this. Let's write it over here. So first term will be m square because it is m cube. After that it will be m square. Here it is 6m square. So you have to get 5m square further to make it as 6m square because it is m square. 5m square, you will get 6m square plus 5m into 1. So it will be 5m, but here it is 9m. So we have to get further 4. So it is 4. So this is the factorization. Now it will be 4 into m plus 3. Okay, so this my entire term of m cube plus 6m square plus 9m plus 4 is written as m plus 1 into m square plus 5m plus 4. Here m plus 1 and m plus 1 will be cancelled. Okay, so I will be left with 1 by m plus 2 Now this one I will solve by splitting middle term. To understand the splitting middle term, again go through my operation classes. Okay, so it will be m square plus m square plus 4m plus m plus 4 by 4 into m plus 3. Okay, so I had splitted 5m as 4m plus m. So you will get it as m plus 4 and m plus 1. Okay, so here it will be m plus 4. We take m common plus 1. Here again it is m plus 4 by 4 into m plus 3. And here you have 1 by m plus 2. Right? So you have your 1 by m plus 2. Here it is m plus 4 is now common in this. Right? So you can write this factorization as m plus 2 m plus 3 into 4. Okay, 4 into m plus 3, 4 into m plus 3, here m plus 2. Now with factorization we got in numerator it has, confusing. Okay, in numerator we got it as m plus 1 and m plus 4. Okay, so it is m plus 1 m plus 4 by 4 into m plus 2 into m plus 3. We had received or we had arrived what we had anticipated, right? We had anticipated that it should be m plus 1 m plus 4 by 4 into m plus 2 m plus 3. So we got it as m plus 1 m plus 2 by 4 into m plus 2 into m plus 3. So my R.H.S of Pm plus 1 is true. Okay, so my Pm plus 1 is true. That's why my conclusion is Pn will be true. Okay, this completes the 6th problem. Now let's go to the 7th problem. Now my problem is Pn, it is 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 into dash 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 up to 1 plus 2n plus 1 by n square. So what is the specialty of this L.H.S is, here the terms are not in addition. All terms are in multiplication. You see multiplication sign over here. Okay. Now this nth term, let's verify that. This nth term is 2n plus 1 by n square. In place of n, let's put 1. Then it will become 2 plus 1, 3 by 1 square, 3 by 1. So we are getting first term. Now let's substitute 2 in place of n. It will be 2 into 2 plus 1 by 2 square. It will be 5 by 4. This will be my second term. Okay, this will be my second term. Now if you substitute 3, then you will get 1 plus 7 by 9. So like that, this nth term is framed. So the product of these n terms is equal to n plus 1 whole square. This is what we have to prove. So my R.H.S is n plus 1 whole square. Okay. Now let's start the solution. First one, P1. For P1, my L.H.S. For L.H.S, let's put n is equal to 1 in that. So we will get it as 1 plus 3 by 1, which is equal to 4. Right? Now what is R.H.S? R.H.S will be n equal to 1, you substitute, then it will be 1 plus 1 whole square, it will be 2 square, which is equal to 4. So my L.H.S and R.H.S both are equal. So my P1 is checked. My P1 is true. Now let's come to the concrete statement. Now for my concrete statement, it will be 1 plus 3 1 plus 5 by 4, 1 plus 7 by 9 into 1 plus 2m plus 1 by m square is equal to m plus 1 whole square. So this is my concrete statement. Okay, this is my concrete statement of PM. So this is our PM. Okay, now let's move on to our induction step, which is our PM plus 1. So my PM plus 1, what will be my LHS? LHS will be 1 plus 3, 1 plus 5 by 4, dash dash dash, 1 plus 2m plus 1 by m square, and my into m plus 1's term will be 1 plus 2m plus 3 by m plus 1 whole square. Okay, so I had substituted n is equal to m plus 1. So product of 1 plus 3, 1 plus 5 by 4, dash dash up to 1 plus 2m plus 1 plus m square. So these are my first m terms. Okay, these are my first m terms. My m plus 1 term is 1 plus, in place of n you substitute m plus 1, then you will get 2m plus 2 plus 1, so it will be 2m plus 3, so 2m plus 3, and in place of n you substitute m plus 1, then you will get m plus 1 whole square. Now let us anticipate that how my RHS for this PM plus 1 should look like. So my RHS should be, in place of n you substitute m plus 1, so it should be m plus 2 whole square. So this is my desired RHS, or this is what we anticipate at the end of the solution of this PM plus 1 statement. Now for this m statement, it is equal to m plus 1 whole square. So let's substitute this m terms with m plus 1 whole square into, everything is in product, okay, into 1 plus 2m plus 3 by m plus 1 whole square. Are you getting? Okay, it is m plus 1 whole square because this entire term is m plus 1 whole square, and it is 1 plus 2m plus 1 3 by m plus 1 whole square. Now let's take m plus 1 LCM here, then it will be m plus 1 whole square plus 2m plus 3 by m plus 1 whole square. And here you will write m plus 1 whole square. So what we had done, we had taken LCM of m plus 1 whole square. Okay, so this m plus 1 whole square and this m plus 1 whole square will be cancelled. Alright, this m plus 1 whole square and this m plus 1 whole square will be cancelled. So this m plus 1 whole square will be m square plus 2m plus 1, and it will be 2m plus 3. So let's write it down. So I will use this side of the board. So I will rub this out, check step. So it will be n square plus 2m plus 1 plus 2m plus 3 whole divided by nothing, it is 1 only. Okay, m plus 1 is cancelled. So this will be 2m plus 2m, it will be 4m. So it will be m square plus 4m, and this 3 plus 1, it will become 4 by 4. So this is m plus 2 whole square. Okay, this is m plus 2 whole square. So we achieved that RHS of PM plus 1 is m plus 2 whole square, right? So this is what we had anticipated. So my PM plus 1 is true. Okay, so my PM plus 1 is true. This is the conclusion, that my PN is also true. This completes the 7th problem. If you are happy with the content in this video, please press like, share and subscribe. For the further problems, stay connected for workshop session 2. Thank you.